Alright everyone, you notice I didn't put the syllabus up at the start of this one. That's because this video is very much a part 2. If you haven't seen the last one, go and have a look at that. That was electronic structure. It's not really going to make any sense unless you watch that one first. Okay, so we're just going to carry on exactly from where we were last time. So what we learned last time, just to kind of sum it up, we learned that the number of protons and electrons is the same to make it neutral. That's because protons are positive and electrons are negative. And we also learned that electrons are arranged 2, 8, 8, and their position in the periodic table is affected by the number of electrons in the outer shell and the number of shells. Okay, so what we're going to have a look at today is we're going to have a look at isotopes and ions. And they are two different words. We'll need to know the vocabulary. What they are is when the number of subatomic particles in an atom changes. Okay, let's take a little look at that. All right, let's start with the idea of ions. So we need a little bit of background first. These group 8 elements over here, the ones that are in the very right hand column on the periodic table, they've got a name. They're called the noble gases. And they're called noble gases because they don't interact, they don't react. They are really, 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 really unreactive. Okay, so helium, neon, argon, krypton, xenon, radon, they're really, really, really unreactive. They just don't form compounds, they don't react with other elements. And that's because they've got that full outer shell. If you remember last time, we had a look at these and they've got full outer shells. So this has got 2, 2, 8, 2, 8, 8, and so on. That means they've got full outer shells. All the other elements are jealous. Obviously they're not actually jealous, I don't think, but what they want is to be unreactive. They want to be stable. So they want to be like the noble gases. I've put one in a bunch of inverted commas there because they don't want anything. They're not alive. But they want to be like the noble gases. They're trying to get a noble gas electron configuration. And they can do that by gaining or losing electrons. Let's take a look at lithium. So if you remember, lithium was 2, 1. I will draw it out just super quick. So lithium is 2 electrons and 1 electron. Okay, it's got no charge. Why does it have no charge? All of these electrons have a negative charge because it's got 3 protons. If we have a look at the periodic table there, it's got 3 protons. So it's got 3 plus and 3 minus. That adds up to a total charge of 0. It wants to be like the noble gases. It wants to have a full outer shell. How can it do that? Well, it takes the shortest route possible. Which noble gas is it most like? It's most like helium. It's closest to helium. Bearing in mind you can go this way or it can go this way. Going left, going down by 1 element, gets it to the noble gases much more quickly than going right, having to go up by 7 elements. So what's it going to do? It's going to try and be like helium. So let's have a little look at what helium looks like. Helium is just got 2 electrons in its first shell, and that's all it's got. Now, that looks very similar to lithium. So how can lithium become like helium? It can lose the first electron on its outer shell. So what's going to happen is we're going to get lithium with just that and that. Now that changes the properties of the lithium. The lithium has now lost an electron. So it hasn't changed the number of protons. It's still got 3 plus. But now it's only got 1, 2 minus electrons. So it's got 2 minus. That is a total, it's not 0 anymore, of plus 1. So this has a charge, so we put some brackets around it to show it's an ion, of plus 1. Now in chemistry we don't need to write the ones. I would write that, the symbol, as Li with a little plus in the top right hand corner. It does matter that it's in the top right hand corner. Where you put the numbers in chemistry really does matter. If it's in the top right, that tells us it's a charge. Okay, so we've got lithium plus 1. That is what is called an ion. So an ion, let's have the definition. An ion is a charged atom, and then I'm also going to put something we're not going to look at right now, group of atoms, because you can have ions that are more than one atom, and they are formed when an atom gains or loses electrons. So hopefully we can see here that by losing an electron, it's got a positive charge, and that's somewhere that students often trip up on. Because we're losing an electron, we're taking away a negative. If you minus a minus, you get a positive, you get a plus. So atoms that have lost electrons are positive ions. Okay? And the atoms that do that are metals. All metals form positive ions. Also hydrogen. So when I say all metals, hydrogen does so as well. Okay? So it is going to lose an electron. So hydrogen, for example, will be H1, and to get a full outer shell, it loses that one to have nothing in its outer shell. Let's take a little look at another one. Let's just look at beryllium, the next one along. So beryllium has got 4 electrons, so it's going to have 1, 2, and then 2 in the next shell, because I'm following the 288 pattern. Pause the video here and figure out what its ion is going to be. Welcome back. I don't know if you actually paused the video. So that's what it looks like. It wants to be stable. What can it do? Well, it's quicker to go down by 2 than up by 6, so it's going to try to be like helium as well. So it is going to lose 2 electrons this time. So it's going to lose 2 electrons. So beryllium, it's going to have the outer shell. Now notice we don't draw the empty shell because it's not there anymore. It's not a thing, it's a place. So it's going to have a 2 plus charge. Why is that? Well, it's still got 4 positive protons, but now it only has 2 negative electrons. That gives us a total of 2 plus. So the charge, the positive charge, is the number of electrons that have been lost. Okay? Let's just take a look at one more. Let's have a look at magnesium. So magnesium is, I'm not going to write it all out, I'm not going to draw it all out, let's just have a look. So magnesium is in group 2, period 3, so following the rules from the last video, we know that it's 2, 8, 2. How can I get a full outer shell? I can get rid of that 2, becoming 2, 8. So it's lost 2 electrons. That means the magnesium ion is Mg2+. It's got positive 2 charge. Okay? So that's positive ions. What about something over here? What about something like fluorine? Okay, so I'm going to have to make some room. So fluorine is, it's got 9 electrons. So if I follow the rule from last time, a fluorine atom is going to have 1, 2, and then it's going to have 7 because it's 2, 8, and it had 9, so it's going to be 7. So there's 7 electrons. Alright, so it wants as well to have a full outer shell. So how can it do that? Well, it could lose 7 electrons. It could go all the way down and get to helium. But it's much easier to just gain 1 electron, like that. Okay? So just gain 1 electron, and that lets it have the same as neon. And what we do, we represent an electron that comes from a different source with a different symbol. So I'm going to put a cross to show that this electron came from somewhere else. So what's the charge going to be here? Well, it's still got 9 protons, which is plus 9, but now it's got 10 electrons, which is minus 10. If I add those together, I get a total of minus 1, so the total charge is negative. If we take a look at another one, let's have a look at oxygen. So I'm not going to write it all out, but oxygen, so it's got 8 electrons, so that's going to be 2, 6. How do I get that to a full outer shell? Well, I add 2 electrons to make it like neon. Electrons have a negative charge, so that becomes 2, 8, 2. It's added, doesn't become 2, 8, 2. I'm sorry, misspoke. Becomes 2, 8. And that means I've added 2 electrons, so an oxygen ion has a 2 minus charge. The fluoride ion from before has an F minus charge. So, atoms that gain electrons are negative ions. And non-metals, now notice I haven't put the word all here because the noble gases don't gain electrons. So non-metals form negative ions because they gain the electrons. So it's an imbalance between the protons, which are positive, and the electrons, which are negative. Okay, let's have a little look at what happens now when you change the other subatomic particles, the neutrons. Okay, so notice so far I haven't talked about changing the number of protons. That's because you can't change the number of protons. The number of protons that's in an element determines which element it is. So I've got, for example, carbon here, which has 6 protons, and if I'd changed it to have 7 protons, it would become nitrogen. If I changed it to become 8 protons, it would become oxygen. So you can't change the number of protons. You can, however, change the number of electrons, as we've just seen. That makes an ion. And you can change the number of neutrons. And neutrons are when you change the number of neutrons, that's going to make something called an isotope. So I've got here a picture from the periodic table. Carbon, 6, 12. The 12 is the mass. And that is number of protons plus the number of neutrons. Because we know we've already got 6 protons, we know that it's going to have 6 neutrons to make 12. So protons, 6, neutrons, also 6. But that's not actually the only type of carbon that exists. On your periodic table, you are only given one type of mass. That is the most common isotope. But what could also exist might be what we call carbon-14. Now I'm just using this as an example. There's isotopes of lots of different elements. And carbon-14, so 14, that's the mass, which is again number of protons plus the number of neutrons. So the number of protons doesn't change, that's 6. The number of neutrons is going to be 14 minus 6, which is going to be 8. They're both still carbon. They're both still got 6 protons and 6 electrons. But they have a different number of neutrons, and that's called an isotope. And we can see here, this diagram, the difference between carbon-12 and carbon-14. So when you're asked in the exam for a definition of an isotope, this is the definition that they're looking for. And every word here matters. So it's atoms of the same element with the same number of protons but a different number of neutrons. There are other ways of saying that. So you could say same atomic number, different mass, or different nucleon number. It's a word we used in a previous video there. Now the thing about isotopes of an element is that chemically they are exactly the same. So isotopes have the same chemical properties. And now why is that? Well, the reason that they have the same chemical properties is because chemical properties are determined by the number of electrons in the outer shell, the number of valence electrons. So we can see here we've got 4 in each. So the same chemical properties. This is because they have the same number of outer shell electrons, because the number of electrons does not change when you have different isotopes of the same element, only the number of neutrons. Okay, now we know about isotopes, we know about ions, and we know about electronic structure. Let's finish off this video with a little question. Alright, so here is the question, past paper question. It's quite a nice one. It's 8 marks, but don't get too intimidated because it's actually lots of little questions. And what you have to do, complete the following table, which gives the number of protons, electrons, and neutrons in each of these 5 particles. So we're given here the number of protons, number of electrons, number of neutrons. Now, number of protons tells us what element it is. So what we have to do is look at our periodic table. Hopefully you've got one there with you. And the periodic table, we look for the element with 19 protons, and we will find out it is potassium. So I'm going to put the symbol for potassium, which is a K. But I'm not quite done. Now the number of electrons and the number of protons, they're the same. That means it's not an ion. We've got no charge, so I don't write anything in the top right. The number of neutrons is 20. So 20 plus 19 gives me the mass. So what I'm going to do is I'm going to write 19, just following this pattern that they've got here. Now notice these have actually got them the other way around, but that doesn't matter. You can put them either way around as long as you've got the smaller number and the larger number. So I've got 19 protons and I've got 39 mass. Because how did I get 39? It's 19 plus 20. That gives me the mass, 39. Alright, so now I look at the second one, I've got to do that the other way around. So it tells me it's iron 5626. The number of protons is going to be the smaller number, so that's 26. The number of electrons, there's no charge, so that tells me that it's going to be the same as the number of protons. So that's also going to be 26, because no charge. Now the number of neutrons is going to be 56 minus 26, because remember it's the larger mass number minus the proton number, which is 30. So I've got 30 neutrons there. Okay, I have to do it again with this one. So the number of protons is 3. I look at my periodic table and I see that lithium has 3, so I put the symbol for lithium. Now this one's a bit different. It's got 2 electrons. Oh, it's got a different number of protons and electrons. They don't equal each other. So that means it's got 3 protons, 3 positives, 2 electrons, 2 negatives. It's going to have an overall charge of +1, which I can represent just with a plus. So the number of protons is 3. The mass number is 3 plus 4, which is 7. 3 protons, 4 neutrons. Okay, got to do it backwards again here. So the number of protons is very easily, it's always just the smaller number. This time though it's got a 3 plus charge. So that tells me that this, again, these numbers are not equal. So I've got 31 positives and I need to make 3 plus, so I'm going to have 3 fewer electrons than I'm going to have protons. So it's going to be 31 minus 3, which is 28. So we're going to have 28 electrons, because if I add those up together, I end up with +3. And again, number of neutrons is going to be the larger number, so 70 minus 31. 70 minus 31 is 39. So it's going to have 39 protons. And again, last one here. Number of protons is 34. I look at my periodic table, which hopefully you've got handy, and that is an element called selenium. Again, the number of electrons and protons are different, except this time there's 2 more protons than electrons. That means that I'm actually going to have a 2 minus charge, because it's gained 2 electrons. Number of protons is always going to be just the number there, and then the number of neutrons plus the number of protons gives me the mass number, so 34 plus 45 is 79. So that's how you do that one. Sorry, these videos seem to be getting a little longer. We'll just try to squeeze it all into one, but that's fine. You can jump around, look at the information that you do need. But again, thanks for watching, and that's atomic structure. Next time, we're going to look at how these elements stick together, which is atomic bonding. See you next time. As always, if you want me to go over a specific question, send me an email. If you're one of my students, to my school email, if not, to the channel email. Again, thanks for watching.